Hi everyone, today we're on day 4, 10.2 notes. We are moving on to law of cosines. So law of cosines should be used in triangles that have side, 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 and side angle side cases. Okay, if it is not one of those two, then you would be using law of sines. Okay, so over here we have our various formulas that we are going to be using in equations depending on what side we are looking for. And when solving a triangle, we want to avoid, if possible, side-side angle cases. And then you will also want to start and end with the same law. So what that means is if we start with law of cosines, then we want to end with law of cosines. And if we start with law of sines, then we would end with law of sines. So let's go ahead and look at this first example. We are trying to find the value of x. So what we have is x is across from angle B, so I know that that is my side B, and I do have a side angle side triangle. So the formula that I'm going to want to use is solving for side B. So we have b squared is equal to a squared plus c squared minus 2 times a times c times cosine of angle B. So b squared is just going to be my x squared. Then I have 7.3 squared plus 11 point, well, I guess actually those are switched. 11.5 squared plus 7.3 squared minus 2 times 11.5 times 7.3 times cosine of 40 degrees. So since my variable is on the left-hand side, I can go ahead and just type everything on the right-hand side into my calculator. And if we do that, you should get that x squared is about 56.92 centimeters. So then we could take the square root and we find that x is equal to approximately 7.5 centimeters. Okay, and number 2, we want to find all of the angles in the triangle if we are given the side measurements of A being 33, B being 7, and C being 37. So we're going to want to sketch a non-right triangle. And let's just label A, B, and C. Side A is 33, side B is 7, and side C is 37. So let's start out with trying to find angle A. So if I want to find angle A, then I am going to be using my equation that has cosine of A in there. So what I want to use is A squared is equal to B squared plus C squared minus 2 times B times C times cosine A. So A squared, we've got 33 squared equals 7 squared plus 37 squared minus 2 times 7 times 37 times cosine A. Okay, so then we can go ahead and try to do some math here. So if I evaluate some of this, and if we do 33 squared and then subtract our 7 squared and subtract our 37 squared, we will end up having negative 329 is equal to, and then negative 2 times 7 times 37 is going to give me negative 518 cosine A. So I will color code a little bit of what happened to everything here. Okay. So now I would have 329 over 518 is equal to cosine A. So to find out angle A, I'm just going to take the inverse. And from here, we find out that the measure of angle A is equal to about 50.6 degrees. Okay, now we're going to repeat the same process to find the measure of angle B. Okay, so to find the measure of angle B, I'm just going to write off to the side. I would have B squared is equal to a squared plus c squared minus 2a times c cosine b. Can substitute our values in. 7 squared is equal to 33 squared plus 37 squared minus 2 times 33 times 37 minus cosine b. Okay, if we do some algebra here, 49 is equal to 2,458 minus 2,442 cosine b. So I've got negative 2,409 divided by negative 204,042 is equal to cosine b. When we take the inverse, we will find out that the measure of angle B is approximately 9.4 degrees. So last, I still need to find the measure of angle C, but remember the sum of a triangle is 180 degrees. So angle C is going to be equal to 180 minus 50.6 degrees minus 9.4 degrees. So we find that angle C is approximately 120 degrees. Okay, in number 3, we have a regular pentagon, and it's inscribed in a circle of radius of 1 unit. Find the perimeter of the pentagon, and then our hint is telling us to first find the length of a side using the law of cosines. So if we recall back from geometry, if we have a regular pentagon, that's telling me that all of the sides are going to be congruent. Okay, so now we also know that we have a radius of 1. So if I draw in some radii, I can see that I have a triangle, and they each have a length of 1. Okay, now since we have a pentagon and it's a regular pentagon, I am going to end up with 5 congruent triangles. I also know that I need to find the measure of that inside angle. Well, the sum of these angles are going to be 360. And if I divide that by the 5 triangles that we have, that is going to give me 72 degrees. So I know that this internal angle is going to be 72 degrees. So now I have a side angle side triangle. Okay, so from here I can use my law of cosines to find the measure of our side right here. Okay, so I would want to use x squared is equal to 1 squared plus 1 squared minus 2 times 1 times 1 times cosine 72 degrees. So I have x squared is equal to approximately 1.382. When we take the square root, we find that x is equal to 1.18 units. Okay, however, we want the perimeter, and a pentagon has 5 sides, so I would take 5, multiply that by my 1.18, and we find that the perimeter of this pentagon is going to be 5.9 units. Okay. Our last problem for today, this one's an important one because this is what's going to pretty much be the rest of chapter 10 are going to have a lot of problems like this. So we have town B, and it's 26 miles from town A at a bearing of south 15 degrees west. Town C is 54 miles from town A at a bearing of south 7 degrees east. We want to compute the distance from town B to town C. And then we're going to round our final answer to the nearest mile. So for these problems, I think to start it out, it's easiest if we have an XY plane. and we label it with our north, east, south, and west. So from here, we can kind of sketch what's going on. We are given information about town B and town C, so let's go ahead and let town A be at the origin. So now town B is 26 miles from town A at a bearing of south 15 degrees west. So that means I am going south first, and then I'm going west 15 degrees. So it's going to be somewhere over here. So I know that this is 26 miles, and I also know that this angle right in there from the south to the west is going to be 15 degrees. So next we have town C, and that's 54 miles from town A at a bearing of south 7 degrees east. So again, I'm going south, but then I'm going east. So that distance is 54 miles, and this angle is going to be 7 degrees. Okay, so now if we notice, we have a triangle, a non-right triangle. So I'm just going to re-sketch this up here. So we have A, B, and C. AB is 26 miles, AC is 54 miles, and then angle A is going to be 15 degrees plus 7 degrees, so that gives me a total of 22 degrees. Okay, we're trying to find the distance from B to C, so that's what we can go ahead and label as X. So if we notice again, we do have a side angle side triangle. So I want to find side X, which is across from angle A, so I'm going to be using our law of cosines with A squared as our equation. So I have A squared is equal to B squared plus C squared minus 2A times C times cosine of 22 degrees. So let's substitute our values in. Okay, and since our variable is all by itself, we can go ahead and type all of that into our calculator, and we find that x squared is about 988.5 miles. And if we take the square root of that, we then find that x is about, we're rounding to the nearest mile, 31 miles. So the distance from town B to town C is about 31 miles apart.